Okay, we're in the big leagues now. It's time to talk about systems of equations. Excuse me. This is kind of where we kick off into the big realm of algebra, but I'm making it sound much scarier than it is. So, what is a system of equations? So, simply put, and this is an oversimplification, but it is good enough for what we're doing. A system of equations is two or more functions. In this case, we're talking specifically for this entire unit about linear functions graphed on the same graph. Okay, so it's two functions that are connected together. They can connect together in three different ways. Okay, so let's look at the three different types of systems. So the first one is where the systems they cross at a single point. Okay, so these two they cross at a single point, right? So they cross at one point and they have one solution. And that one solution is where they cross. Okay? So they have exactly one solution, and that solution is right there. That's the solution to this system. Now, this system is considered to be consistent. And independent. Independent. Right? So that's one type of system. The next type of system is one where it's two lines that are graphed right on top of each other. These are probably not perfectly graphed right on top of each other. You can kind of see one. If they were perfect, then you wouldn't be able to see the one underneath, right? All right, but I wanted you to be able to see and understand what's going on. So they are two lines that are graphed in the same place. So, they have infinitely many solutions because they're always touching. So they have infinite solutions. So if you have a system that is two of the same line, they have infinite solutions. And they are considered to be consistent because they have an answer. And they are considered to be dependent. They're codependent. They're dependent on one another, right? Okay, so the third and final type of system, give you a second to guess what it is. What do you think? It is one. Oops, I uncovered the wrong one. How about that one? Okay, where these two lines are parallel, right? So they have they have the same slope for one thing, right? Same slope, which means that they're parallel, which means that they have no solution because they never, in fact, touch. Right? They're never, ever going to touch. You extend those on forever and ever and ever, and they never will touch because they're parallel. They have the same slope. They have no solution. And these are considered to be inconsistent. Okay, so let's look at a couple of examples of if we are asked to graph a system. Now, it's worth noting that generally speaking, after this particular lesson, I'm not going to ask you to graph systems much more. We'll solve the systems algebraically because solving them by graphing is the least easy way to get a precise answer. Okay, but I do include this lesson, even though this is the last time we're going to mess with this particular graphing of systems. I do it because it lets us understand what systems are and understand what the answers that we're going to learn other methods to get are telling us. Okay, so we're going to graph. We're going to, excuse me, we're going to determine the number of solutions. Determine number of solutions. And what is the solution if it has one? Okay. And the system we're going to graph is y excuse me, equals -3 x plus 10 and y equals x minus 2. All right, I'm going to have to do my best here because I don't think I have 10 marks going up. So we'll do the best we can. Actually, you know what we'll do is we will drag this one in and we'll offset it. How's that sound? Drag that guy in and give him an overlay so he's not so violently dark and hard to, and we want him hard to see in a different way. Plop that guy and hide this one. Yeah, that'll work. That'll do what we need it to do. So now we're going to move I'm going to move my axes off center so that I have enough space to graph both of these. So let's move it from here. So there's one axis, and then the other one can be right here. So this is the x-axis, and this is the y-axis, right? That'll work. That'll get us what we need. So to graph this top one, we're going to go back and go to graphing linear functions, right? So we're going to count up 110. We're going to count up to 10 on the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to put a dot, and then we're going to count down 3 over 1. And we're going to connect those dots. Down 3 over 1, right? And I'm going to keep on going down until I've got a line in there. Now, for our other one, let's do this one in yellow. That seems reasonable. You can tell the difference between the two. We're going to go down 2 on the y-intercept, and then we're going to go up 1 over 1. And then we're going to go up 1 over 1, and we're going to keep on doing that till we have a line, right? There we go. Okay, so this system has one solution, right? Which means it's consistent and dependent. And its solution is right here, which is the point. Oops. 3, 1, right? There we go. There's that guy. Let's do one more example. We can leave it on this offset grid. Let's do example 2. Example 2 is going to be the same instructions, but we're going to do 2x minus y equals -1, and 4x minus 2y equals 6. So in order to do this one, we've got to solve each one of these equations for y. We've got to get them in slope-intercept form, right? And so we're going to subtract 2x on this one. And on this one, we're going to subtract 4x. Those cancel. On the top one, we're left with -y equals -2x minus 1. And then on the second one, we're left with -2y equals -4x plus 6. All right, so now we're going to divide by -1 on the top one and divide by -2 on the bottom one. Okay, so on the top one, the -1's cancel, and then on the bottom one, the -2's cancel. So on the top one, we're left with y equals +2x plus 1. And then on the bottom one, we're left with y equals +2x minus 3. Okay, so these two are not the same line, right? But they do have the same slope, so we actually already know the answer, right? We already know that this one is going to be inconsistent and have no solution. But let's go ahead and graph it so that we get it on there. Let me grab my one with axes again. So let's graph this one in this yellow and this one in that yellow. Those look different enough? Nope, not at all. Let's do it in this kind of orangey color. That'll work better. Okay, so this first one we're going to graph, and we're going to start up at up 1, and then we're going to go up 2 over 1. And then we're going to keep on doing it until we get a line. Right? So there it is. And then this next one, we're going to go down 3. And then we're also going to count up 2 over 1. I'm going to do the same thing. So these guys are parallel, right? Which means that there is, in fact, no solution. All right, that's graphing systems. That's what the answer to a system of equations means. In the next couple lessons, we're going to talk about how to solve systems algebraically, which is good because if the, like, say the two things cross like this, like in between tick marks, then it's like, okay, what's the answer to that? Well, it's pretty easy to find if we just use a little bit of algebra to get us there. We will see you in those lessons. If you're one of my students, do your homework, all the things. If you're not one of my students, thanks for joining us. Don't forget to like, comment, and subscribe. It helps us out, helps us be able to get all these lessons to you for free. See you later. Bye-bye.